Okay.
All right. So welcome everybody to the community call today. We're going to kick things off with Mark Studley talking about verbose JIT. So Mark, feel free to steal the screen.
Okay, so I think people should be able to see my screen now. Is that visible?
Yes.
All right. So I'm going to give a quick primer today on how to get JIT verbose logs and how to read them. But I need to go through a couple of things first. So what is the verbose JIT log? It's basically a summary of what methods were compiled by the JIT and some of the compilation heuristic decisions that get made while the JIT is operating inside the JVM. It is not the more detailed logging that's available for how the compiler optimized and generated the code for a method and a tree of methods that get inlined. I can do that another day, but that's not something that I'm going to be talking about today. That's not what the verbose log is for. So before I can actually talk about the verbose log format, there's a bunch of, you need to understand a little bit about how the JIT itself is actually working so that you'll recognize the things that are in the log entry. So this is a quick primer. I'm not going to go through this in detail, but primarily I wanted to just point out that methods obviously start out interpreted like they do in just about every JVM. And then there are a sequence of compile levels, we call them optimization levels, that are sort of temperature-based, cold through warm, hot, and scorching, which basically trade off how much compile time we're willing to spend for how much faster the code we get out of it is expected to be. And so in a verbose log, you're going to see entries that list things like the optimization level, cold, hot, warm, etc., that was used to compile a particular method. There are a variety of different heuristics used to decide which ones. I'm not going to go through that here, but there's a little bit of information in the slide. And then there's a few interesting names that you'll see in verbose logs, which I won't talk about here, but it could serve as a reference for you if you're playing around with your own verbose logs. Okay, I am now going to try to share a command line prompt. See how this goes. Can everyone see that? Okay, great. So I work on a MacBook, which doesn't unfortunately run OpenJ9 natively yet. My fingers keep crossing for getting it soon, but I can run it using the Docker images that it.
Mark, are you still there? We still see your screen, but you have gone quiet.
So just a dash version to see what thing we've got in here.
You froze.
Verify that we are in fact running with OpenJ9.
Hey, Mark.
Again. Can you
Mark,
hear me
froze.
still?
Yeah. All right, there you just came back. Do you want to try again?
You guys are frozen for me. That probably means I'm frozen for you.
Well, you just unfroze.
Okay, can you hear me again?
Yeah.
Yeah. Okay, let's try again. Sorry, that might make my presentation longer. So we can verify that this is OpenJ9 that's being used as the JVM inside this package, and we're running with OpenJDK 1.8. So I'm actually going to use the very simplest Java application you possibly can, which is not Hello World, but is actually dash version. So if you want to generate a verbose log with OpenJ9, all you have to do is add this -x JIT verbose option, and that will helpfully provide a whole bunch of information about what the JIT's doing. Now that's a lot of stuff. So let's scroll back up here and look through what's actually here. So there's a bunch of hash info stuff that gets printed out first. These are things that are relevant if you're trying to understand what JIT you're using. So for instance, you can get the SHAs of the JIT and the date of the JVM. You can get some information about the processor that's running that the JIT sees and how many processors it thinks it has access to. There are sections here for the AOT options and JIT options. I'm going to ignore the AOT options for now. But the JIT options, you can see under the options specified, it actually includes the verbose. That's the setting that I added to -F JIT. So if I added other options, it will show here, and then a few other sort of interesting things that are relevant for the JIT's operation. Start time, memory, how much of the CPU we think we have we're entitled to use, and so on. And then a sequence of lines to describe the methods that are being compiled. So this first line here starts with a plus. The plus means that this is a successfully compiled method. If it started with an exclamation mark, it would be a failed compilation. There are a few other characters that can be used. And each line basically corresponds to a single compilation event, right? So in this particular case, at the cold optimization level, we compiled getColor class. We generated the code at this code range. And there's some details about the compilation queue statistics when we did the compilation. There's some internal pointer stuff. This method is actually just a native method. So what we're actually compiling here is an accelerated JNI transition into this native getColor class function. That's why the bytecode size is so small. It's just a call. And then some other stuff. And so you can see there are a bunch of different lines for different things as we're compiling things. And eventually you can see the actual output from the dash version output. That's this stuff here mixed in. I'll talk about that in a sec. And then once we're done, there's still some stuff being compiled on shutdown. So that's a little bit interesting. Now, you might not kind of like all of that stuff to be embedded in your output. So there's actually an option, vlog, which you can use to store it to a file. So now we just see the output normally. And if we look in the current directory, there's a file called vlog file. And it's usefully suffixed with some interesting stuff here, just so that you can distinguish if you have multiple JVMs running, or if you do multiple runs, you don't necessarily just overwrite the verbose log file from any one run. So it's tagged with the date. This is the time, and this should be the process ID of the JVM that ran. If you don't like having that suffix or all that suffix logs there because it's hard to find things, or you actually do want it to be override, you can do that. And now if we look inside our command, we have vlog file, which is the same thing that we saw with all the wonderful output that we had before. Now, none of those compiles are very interesting because by default, we don't actually do a whole lot of compilation during dash version because it's very fast. There's not much time to do very much compilation. So I'm going to fake it out a little bit and add an override to the JIT heuristics to say, I want you to compile after 5 invocations. And so that's going to generate a whole whack load of more stuff. You can see now we have some warm compiles in here. And they're methods with, more interesting methods. They have a bytecode size of 72. And the queue is actually getting, much larger as we get through the compilation here. And you can see even at the end, if we go to the last successful compile here, there were still 324 methods queued to be compiled when we reached the end of the JVM. The JVM shut down and just gave up on compiling that. That's because I asked it to compile so many things. And you can also see some examples of some failed compiles. These ones are failing because the JVM is in the process of shutting down. So you can't shut down and generate code at the same time. So we fail the compiles and then we get out. There are some reasons why you might fail compiles during a run for less catastrophic reasons, but I don't really have time to talk about that too much here. The sort of last topic that I wanted to bring up is that there are even some sub-options that you can provide on as part of verbose that will give you some additional information. One of the most important or useful ones is this one. We use this one all the time. It adds some information into the verbose log that makes it a little bit better. You can understand a little bit more about the performance of what's going on with the compiler threads. So for example, well, let's just pick up this guy. So it adds this new section to each verbose entry. So you can get the time that it takes to do the compilation. So that's 660 microseconds it took to compile hash table entry.getValue at warm. And it allocated this amount of memory while it was doing that. So, some methods will use more than others. If we actually had something being compiled that's scorching or hot, it would be generating a lot more memory or using a lot more memory to do the compilation. Finally, the last one that I'll show you, which is one that I like to advertise a little bit, even though it's not perfect. So you can put different sub options together. So compile start is an interesting one. Oh, I didn't even mention compile start before. Sorry. Compile performance uses compile start as well. So it basically prints out a line when you're about to start compiling something. So that's this compiling. This means I'm about to start compiling hashtable.get. And then there's a follow-on line that would be the plus or the minus in this particular case, I guess. Here's the corresponding, I failed to compile hashtable.get. That's an event called compile end. So I'm going to ask for both compile start and compile end. So I know the boundaries of a particular compilation. And then there's an interesting sub-option called inlining that people always ask questions about. And because we use the vertical bar, we have to protect that from the shell. And then the other thing that doesn't work very well in this one, which we should really fix, is that it's not really good for multiple compilation threads, which are on by default. So I'm going to set compilation threads 1 and look at compile start, end, and inlining, and hopefully this will lead us to an interesting compile somewhere in here. It worked before. There we go. Here's a good one. Put val. So I'm going to just highlight the whole compilation event for put val here, which is all of this. Hopefully you can see all that. So this is the compile start line saying that we're about to start compiling hashmap.putval. This is the final, we compiled it at warm and all of its details, and it took, we don't have the time in this one, so it doesn't show the time. But the inlining information tells you what inlining was actually performed as part of this, and it didn't actually inline anything this one. Sorry. This shows lots of stuff that it could have inlined but didn't. Let me see if I can find one that did inline. One method, that's not very interesting. 2 methods. Of course, this worked in the demo that I did myself beforehand. Let's see if we can get a different run and have some. There we go. That's better. All right. This one's even shorter to do. Okay, so now we're doing string.equals. In this case, we actually inline 7 methods into the top level string.equals. It first lists the methods that actually did get inlined. So that's this list here, and it numbers each one of them so that it can refer to them and describe to you the tree of how things got inlined. So -1 in this particular case is the top level method that's being compiled. So we inlined 3 methods into the top level compile, and then we inlined another 4 methods into this number 2 guy, which is if you go across, it's this guy, and that's string.regionMatches internal. Right? So each line gives some data about the method that's being inlined. There's a pointer here which corresponds to, it's an internal pointer called a J9 method, which you can link up to the names. It's hard to see, but there's actually an @22 or an @number at the end of all of these. That's a bytecode index that describes the call that's being inlined. And then this stuff on the right shows the details of the method that actually got inlined there, right? So string.length internal got inlined at a call at bytecode index 22. It also got inlined at a call at bytecode index 28. And then region matches internal got inlined at a bytecode index of, or a call that's at bytecode index 104. And so you can kind of reconstruct the tree of inlines that's happening and what's being inlined and what isn't being inlined into the method. And that's basically where I was going to stop because I think I've run out of time and the freezing probably didn't help. There's lots more to learn here, so I guess I'll just sign off by saying, if you have any questions or if I wasn't clear about anything, feel free to ask questions on our Slack channels, or you can send me email or talk, direct message me on Twitter, whatever. The preferred way is probably to talk on the Slack channel, just because there's a bunch of people that can help with questions, and we can all see the answers to what's being asked. And I'll stop there and pass it back.
Thanks, Mark. Is there any questions from anybody on the call today?
Yeah, apologies, I joined late, but I know you're recording this, right?
Yes.
Okay, great, thanks.
So I did have just one question out of interest while you've done all that, Mark. So the example that you did, which I think was string.equals,
Yes.
am I right in thinking that now every invocation of string.equals will invoke exactly the same code with all those same methods inlined as that compilation that happened then, and that will be true until the JIT recompiles string.equals?
That's correct. It's also possible that some of the inline code bodies can be invalidated, which means...
Sorry, I can't hear you, Mark.
Sorry, I'm unmuted. Can anyone... You can hear me?
Can now.
Okay, good. Sorry about that. It is possible for inline code bodies to be invalidated inside a compiled method. So it's not necessarily the case that you'll continue to execute those inline methods as part of the compiled body for string.equals. But that's obviously the way we prefer it to work, right? So if there are invalidated assumptions, maybe that would cause it. But as long as everything goes smoothly, if you call string.equals, you will end up calling all of those inline methods as part of string.equals, as opposed to doing separate calls to those methods. Does that answer your question?
Yes, thank you. Yep.
Great.
Thank you, Mark. Going to look back at our agenda. I see, Boris, that you've listed the RISC-V project port. So welcome to the call. Do you want to introduce that for us?
Yeah, well, it's just a little shameless plug for my little project to try porting OpenJ9, well, OMR and OpenJ9 to the RISC-V architecture. And the talking about this has been going on. The initial idea to do this came at the 7th RISC-V workshop last November in California, and there were a bunch of guys who were in the J extensions and in the software toolchain meetings, trying to understand what to do about dynamic languages runtimes for RISC-V. And in the brainstorming, we said, well, we can try with an OpenJ9 port, because that just got open sourced, and then everybody kind of got excited, and now we got some ability in terms of funding, you know, to have to devote some time for the project. And it's not really much to show right now, just some experiments of generating code in the TR compiler for the RISC-V. Just very simple stuff. But the good news is that we are doing it and people are interested, and I'm going to be talking about OpenJ9 and about OMR at the next RISC-V workshop, which is going to be in Barcelona in 3 weeks. Going to be doing a poster session about it, and we'll see how people react to that.
That's really cool, Boris. Thanks for coming to the call to tell us about it. That's amazing. I guess I'm curious to hear. Like, obviously, we'd like to hear back how that goes for you. But I think, you know, any kind of feedback that you have for the project on how well the process worked for you, what didn't work well for you, what could have made it easier on you. I think that we'd be really, really interested to hear that.
Yeah. Well, I intend to regularly come to these weekly calls, so
great.
You will hear back from me.
Excellent. Well, you're very welcome to show up whenever you can. Thank you.
Okay. All right. Are there other particular topics in this area that anybody wants to bring up? I know that April 21st, Alex Mitchik, one of the longtime GC developers on OpenJ9, will be talking about Metronome GC. So I have that to look forward to next week. Are there other topics in this area that we want to discuss?
I guess I can sign up to either do, I'm not sure what I'll do yet. I could do a follow-on verbose log thing to talk about more details there if people are interested, or I could also do the sort of an introductory talk on how to generate logs. That's a very sort of more developer focused than user focused kind of thing, but I'd be happy to do it if there's interest. Get me better at doing these lightning talk things.
I can't speak for anybody else, but I'm definitely interested.
All right, well, you can write me down for something.
I've written down both of those options. I haven't assigned a date to it yet, Mark, so you can sort of think through when you want to be doing that.
Okay, thanks.
All right. One of the other items here was a discussion around the JRE packages. We have an item open for this at the Adopt project. There's been some discussion and investigation going on there. Stuart has been involved. I don't know if he's on the call today. There is progress slowly being made there. In terms of the compressed refs packages, I've opened the issue, but we haven't had a chance to make much headway there. If people do have other comments, thank you, Mark, to starting off some of the discussion there. If people do have other comments, please join that item and comment on it or get involved. Just being cognizant of time, given I think we have 40 minutes before our free Zoom kicks us off and we're 25 minutes in. Is there anything else that we want to discuss in this area? Sounds like a no, so I will move on to...
Sorry, Dan, I could ask one question about the compressed refs. I noticed that with IBM's Java, you flipped between compressed refs and not compressed refs with a command line argument. But from what you seem to be saying here, that's not how OpenJ9 works, and that you're looking at some other way of implementing not compressed refs. Could you clarify a bit what's the difference?
So the way we've done that for IBM for years required compiling the VM twice, and it worked out well given our different build practice internally. When we've migrated to being able to build with the rest of OpenJDK, doing that second compile becomes difficult. And so we've looked at, as a temporary measure, providing two packages, one that has the compressed refs VM and one that supports larger heaps beyond the approximately 60 gig limit that compressed refs has. So there will be two separate packages, one compressed and one called the large heap package. Long term, we're looking at ways to move back to having a single package, but we thought this was a good way to get people access to the non-compressed version in the meantime.
Especially since we did have some feedback that there are people who want to try OpenJ9 with larger heaps than 60 gigabytes. In fact, much larger heaps than 60 gigabytes. So we wanted to get an option in front of them so that they could start trying the technology out, before we had maybe the perfect solution for everybody.
So essentially the two modes, if I understand correctly, the two modes require different versions of the JVM and therefore different JDKs.
Yeah.
And in IBM's Java, traditionally, they just included both the VMs and had some magic to flip. So that's a fair summary?
Yep.
Okay, thanks.
I don't see Irina on the call, so I suspect we don't have an update on the issues list.
And she's on vacation the rest of the week, so it's not surprising she's not here.
All right. So I guess we'll skip that and we'll talk about machines. Don't know if Charlie's on the call either, but I touched base with him earlier this morning. We continue to be talking with UNB around or the University of New Brunswick around what capacity they have for machines, and then working through looking at the machines that we have to see what we can send there and get enabled. So there's ongoing discussions. I don't have details or, unfortunately, an ETA on when those will close out, but we're continuing to push to get machines there. Trying to see, is there any other comments that anybody has around machines and availability?
Not sure if you want to update on the Windows machines. We got 4 Windows machines last week, and one of them was set up by Stuart Addison. So I was connecting it to our Jenkins instance yesterday and trying to run a build on it. So I'm just working through a few issues I had with it. So I'll hopefully get that going today or tomorrow, and then we can hopefully get Windows builds into the nightlies and the pull requests hopefully next week.
So Adam, you said hopefully by next week we'd have Windows in the pull request
That's
builds?
the goal, assuming we don't have too many more issues.
That's great news. That'll get us some x86 testing in the open, which is a great improvement over where we are. All right. Next item is the end user experience. Are there any particular issues that we want to discuss here? Or anything new people want to call out? The Ansible pull request, has that been merged at this point? Open that for a minute and just check. Okay, I see that it has not been. Adam, you gave it a looks good to me. Have you had a chance to test it out, given whatever the last changes to it were, and validate that it runs? Oh, I see Adam's dropped off the call. Okay, so I guess I will follow up with him offline. We are nearing the end of our discussions on the Jekyll versus WordPress. We're nearing at least the end of our time limit on this. Does anybody have any further comments to make on this before we move forward with a decision? Sue, do you have a view right now on where we should be going with this, or can summarize the current discussion? Sue, you're on mute. All right. All right, so I think we may have to follow up with this one on the issues list, but if everybody can continue to chime in, and we'll make that call by the end of this week. Sue made a great summary in the wiki issue about how to organize some of our information. So I think given our time limits, I'll suggest people give that a read and discussion there. We're down to 8 minutes at this point. So is there anything left in the agenda anybody would like to explicitly discuss at this point?
So I'll just do a little personal request that I did finally write the community call blog article that I've been neglecting to do for a couple of weeks. So I've posted that on my personal blog site, as unimpressive as that site is, and tweeted it. I put links into the agenda where the topic is. If anyone would kindly retweet and propagate that, I would appreciate it, just so that more people can hear about this. And that's all I'll say about that.
Thanks, Mark, for writing that up. We should continue to push on that to hope that we can get more people here. So, all right. Then looking at the rest of the agenda, continue to work towards the 0.9 release. I'm not sure that we have anything called out as action items for this particular week, other than the non-compressed refs package that I need to work with Adam to make progress on.
I think we need to figure out that we need to get that 0.9 release plan in place so that we can get it through the Eclipse process in time. So I know they only review it a couple of times a month.
We have the initial draft open, thankfully.
Yeah, I know.
It's a matter of putting content in it.
I know. We need we need to finalize that and get it through the process. Yes, it was Jonathan that took it through before, but we will need to do that this time around.
So on that topic, the quarterly updates from Oracle were released yesterday for Java 8 and Java 10. I'm currently assuming that we will wait for this 0.9 release from Eclipse OpenJ9 to combine with that level code to do the next OpenJDK OpenJ9 releases at adopt. Is that your thinking too?
Yes.
I think the timing is reasonable for that, yeah.
Certainly we should be aiming for it.
Agreed.
I have discovered one horrible usability issue today with all of this, with the new Windows builds that we're creating as adopt. Download them and put them on my Windows desktop, and every executable in DLL semantic end protection says it's a virus and quarantines it. So I don't know what we can do about this, but it's claiming. I've never seen these binaries before. I'm not going to let you run them. So I'll try and raise that with adopt tomorrow and see if there's any way around this.
Thank you. That's not really the reputation we want.
All right, so we are down to the last sort of 4 minutes before we run out of time. Is there anything else anybody wants to bring up?
I actually had one other request for Boris. So if there's kind of presentation material or collateral or that poster that you're putting together, if there are links available to that on the web or will become available on the web, I think we'd be happy to put links to that on the OpenJ9 website to try to drive some content there too. So if you have any, please we'd be willing to.
You mean before the actual conference?
Yeah.
Yeah. I'll run stuff by you guys.
Perfect.
In this channel.
Yeah. Thank you.
All right.
I think that's it for me.
Okay, then thank you everybody for joining, and we'll close the call out today.
Thanks. Bye.
Thank you.